Okay, now that we have the G words, I have some extra fun for you right here. Okay, I already typed some of these in because I had to make the recording again. So here we are. Normal blood glucose concentrations are from 65 to 100. We will talk about this. This is your fasting. So just hold on to that for a second. Hypoglycemia. This causes weakness, sweating, rapid heartbeat. In severe cases, it can cause mental confusion. Hyperglycemia. Okay, so write that one down. Hypo with the O, circle the O or circle under here. Hyper. They sound like exactly the same thing. I mean, it's going to be like a matching or something. You're going to miss it. So, hyper causes increased urine flow. Why? Why when you have, so hypo is low blood sugar. Low. Hyper, there's a lot. Hyper, there's a bunch. Hyper is high blood sugar. You have a high blood sugar. Why are you peeing all the time? I think we talked about this, but let's talk about it again. Why are you peeing all the time? Because your kidneys you're killing them. They're like, what is all this blood sugar? Stop. So it's coming in, right? And the kidneys are like, all right, go back out through the blood, deliver all this glucose to the cells and come back with no glucose. And it comes back and it's got all the glucose again. And the kidneys are like, what? So the kidneys are freaking out and they're like, drink more water, dilute this, something's got to be diluted. And so you're drinking, you're just like peeing it out. You're drinking, you're peeing it out. And the kidneys are not, good things are not happening with your kidneys. You're putting a ton of pressure on your kidneys. But that's why you have to pee all the time. That's usually the first stage of people who know they're diabetic. They come to the doctor and they're like, dude, I pee like 25 times a day and I'm so thirsty. It's like dead thirsty. It's like you just ran a marathon thirsty all the time. They're all the time thirsty. They're all the time. This is like the first clue that you may have diabetes. Okay. Okay, so let's say that was you and you do. What are you going to do? You're probably going to take insulin. What does insulin even do? We watched the video in class, but let's just review. Insulin is too far. Insulin is released when blood glucose concentration is high. This is going to be important when you have tons of glucose. You just ate grandma's pumpkin pie and you got a rush of glucose. It's going to trigger the insulin, and the insulin's like, dude, let's get this in the cells. It's going to put all of it that it can in the cells. 2 hours later, you're done. Your insulin has taken all the glucose that it needs into the cells. So insulin is released when blood glucose is high. When you have high blood sugar, right, the insulin's like, hello, we need to do something with this glucose. Its role is to accelerate the uptake of glucose by the cells. So the cells can't get it by itself, so you need glucose. You need insulin to get your glucose into the cells. Versus glucagon. This is the opposite of insulin. Remember the G words? This is the hormone released when blood concentration is low. This is 2 hours after the pumpkin pie. You're like, oh, I'm tired, I'm cranky. Shani's killing me. She's so boring, stupid G words. I know. No. You're like, I love this class. I'm just a little groggy. Your glucagon has kicked in, and it's like, dude, go get the starch flour. Get it? Because we need the glucose from the starch flour. Go get it. Get the glucose flour. So it's released when it's low. Glucagon stimulates the breakdown of glycogen. What is glycogen? The starch flour. I'm telling you. Glucagon is the hormone. Glycogen is the starch flour. Sorry, nothing I can do about that. This is really why they don't let biochemists name things, because it comes up like this. Kind of makes you miss organic, doesn't it? Okay, so we are focusing. Okay, so this is just kind of a little bit of what your blood levels would look like if we're taking blood. So your normal fasting. Now, I mean, this seems like dead obvious, but people are always like, why can't I eat before? Well, duh, because if you have a donut right before, where's your blood sugar level is going to be? Right here. This is normal fasting. This isn't like you fasted for 2 weeks before the blood test. This is like you fasted, 20, like the night before. Usually they say after 9 o'clock or something. So your blood glucose level should be in here. Dude, if they're still up here, your insulin is not working. Most likely, your insulin is not kicking in. If they're way down here, something else is wrong. Something's going on with your glucose. So, and we're also, when we did the urine test, like if you still have glucose in your urine, that's a bad sign. Okay. Oh, I'm always going too far. Why? Okay, in the absence of food, a gradual decline in blood glucose concentration is accompanied by an increase release of glucose from glycogen. Did you get that? I know, I write these sentences and then I'm like, why? That's a huge run on sentences, but let's take it bit by bit. So you're done eating, right? You ate the pie 2 hours ago. A gradual decline in blood glucose, right? So your insulin, your normal, has taken all the glucose in that you need. You've used all the glucose available from your pumpkin pie. Now your body's like, dude, I still need ATP. I still need to breathe and blink and move and think and do all kinds of things. So now you're gonna, so if this is insulin, your insulin was here. Lots of insulin. Your insulin's like, ooh, we don't really need me anymore. What's this? This is your glycagon, who's like, hey, come on, someone go get the starch flour, is accompanied by an increased release of glucose from glycogen. So they're getting the glucose from the starch flour. Yeah, I said it as many ways as I can. As glucose and glycogen reserves are exhausted. So now you've taken all the stuff from your pumpkin pie. You've used all the glucose available from your starch flours. What's happening now? Now metabolism turns to the breakdown of proteins. This is usually bad. By the time you're breaking down proteins, you haven't eaten for a while, or you're on a diet, which is good. I mean, in some cases, I could use to break down a little protein, I'm not going to lie. Some of the adipose tissue could go. But it's all a strategy, people. Let me tell you why. No one wants to be super skinny, because if the zombie apocalypse happens, you really super skinny people are going to die first, and I'm going to live longer because I got some fat stored up. Yep. So the brain and other tissues are able to switch up to 50% of their ATP from ketone bodies and glucose. This is not good. This is like when you're starving to death. By the 14th day of starvation, this is not like, hey, you should try this. This is like bad. Zombie apocalypse kind of bad. But this is just telling you how awesome your body is. By the 14th day of starvation, metabolism has stabilized, and it will use 25 grams of protein and 100 grams of fat each day. So at that point, you've kicked into starvation mode. That's all you're using per day. With adequate water, an average person in this case can survive for several months. You don't want to do that. Don't do that. Don't try it. Trust me. Trust me. Don't try it. Those with more fat can actually survive longer. But once you're in this state, after the 14th day of starvation, you will puke up food. Bad things will happen. So you have to eat food a little bit at a time, because it takes like a day or so to get those processes back. Okay, diabetes. Let's talk about diabetes real quick. This is the most common metabolic disease. Why does it do that? I hate when it does that. Okay. Type 1 or juvenile onset diabetes is caused by failure of the pancreatic cells to make insulin. So it's not even there. It's not like when people are like, oh, I was cured from type 1 diabetes. Maybe, but more likely you had type 2. This is like your own body is attacking the insulin producing cells. Bad news. You're just not making insulin. So there's a little bit of a different strategy here. You again have excessive thirst. Why? We already talked about it. Your kidneys. Abnormally high glucose concentrations in the urine and blood. Again, it's not getting in. So there's a bunch of wasting of the body despite a good diet. Why? What process is your body using now? Is it really getting all of its energy from glucose like it's supposed to? No. It's getting it all from all of your available starch flours. It's sucking those I mean, you can eat cake all day and it's like, I can't use that glucose. I have to use, really, it can't even use glucose. It has to use fat. So it's using your body's own fat. You're basically peeing out the glucose and it's using your body's own fat. So all of a sudden you're losing weight and you're like, what is going on? You're eating, you're thirsty, you're getting thin. And it's because you're basically your body is using all of its available fat. And when we talk about lipid metabolism, you'll see that it goes into right where acetyl-CoA is. That's where the fat process goes in. So you're wasting of the body because your body isn't able to use what you're eating and it's using other processes. The available glucose does not enter the cell and spills over into your urine. So through the same stages as in starvation. So at some point you're starting to kick in that 40. So you can actually survive in that process for months. Your body thinks you're starving. You're losing weight, you're drinking all the time, and it's bad. So this is type 1. They usually catch it pretty quickly. Type 2, or what they call adult onset, is a good, you actually have insulin, but it actually fails to promote, what is the word I had? It fails to promote movement of glucose? No, that's not what I want. It fails to promote, we'll say movement, I guess, movement of glucose across the cells. So it's there, but it's just not doing anything. Either there's not enough, or your kind of insulin receptors are all like caked up with Twinkie goo or something. Type 2 diabetes results when cell membranes fail to recognize. So they don't know you're there. Okay. Really? You're kidding me. Recognize the insulin. So they kind of know it's there, but they don't really. They're like, eh. This state is sometimes referred to as insulin resistance. So in this case, very often you will hear people get cured of this. You hear people like, hey, I started really good diet and exercise, and I sort of cleaned up that whole thing, and I stopped doing it. Some people at some point, they have to inject insulin, or they take different types of medication, or they increase their diet and exercise. Hypoglycemia or insulin shock, by contrast, may be due to an overdose of insulin or failure to eat. Sometimes people are just not eating, and it causes really low blood sugar, and bad things happen. Okay. Glycogen synthesis, known as, it's a G word, people. Do you remember which one it is? I'll tell you which one it is. Glycogen synthesis, known as, let's get this down here. Glycogenesis. Just like the Bible. Genesis. You should come up with a way to remember that. Glycogenesis, like the Bible. Genesis, the first thing, occurs when glucose concentrations are high. So it begins with glucose-phosphate. You don't need to know that. You know how, just erase that, because that's just going to confuse you and make you sad, and just get it out of there. Just say, go away. Okay. Glycogenesis. Okay, that is when glucose concentrations are high. Glycogenesis is going to make your starch flour. The next process that we need to know about is glycogenolysis, the biochemical pathway for the breakdown of glycogen. So glycogenesis, the beginning, makes the starch flour. Glycogenolysis breaks down the starch flour. That may help. Remember, glycogenesis, glycogenolysis. In muscle tissues, glycogenolysis occurs when there is immediate need for energy. So sometimes you use this pathway when you're exercising or when other things happen. Again, we're not talking about glucose 6-phosphate because it's hard and it's just going to make you sad. Here is a visual diagram of this funness. We will probably make some flowcharts and things of this because these G words are confusing. Okay, glycogenesis from non-carbohydrates is basically, I call it the Cori cycle. This is the biochemical pathway by which you, or the Cori cycle. You can also call it Cori cycle or maybe we just flip, maybe we should why can I not spell gluconeogenesis? This is the biochemical pathway for the synthesis of glucose from non-carbohydrates. So you went for a run, you have a bunch of lactate in your muscles, which is making you sore. Your body needs to use that. It doesn't want to waste things. So basically, this is the process by it takes the lactate that's making your muscle sore and it recirculates it back in and puts it back in the process to go into the electron transport chain to make ATP. Right? So it's another G word, and I know you're super excited about it. Lactate. I always want to call it lactose. It's not. Lactate is the process of what happens when anaerobic, so you're not getting enough oxygen when you're exercising, that is causing the pathway to go in another direction. This goes this way with oxygen and does glycolysis and all that stuff. It goes another way and it makes lactate. At some point, the lactate builds up and it circulates back around through the process of gluconeogenesis and it makes ATP. You don't have to know that process. You do have to know what gluconeogenesis does. And it basically does that. It is absorbed from the blood. Lactate absorbed from the blood is converted to